Hi all, I welcome you to the Building Culture podcast where I invite incredibly smart people who build things. Whether they be engineers, entrepreneurs, programmers, hobbyists, or researchers, it does not matter. As long as you're someone who's passionate about building things, I'll find you and podcast you. Hi, all. I want to take a brief moment to thank you all personally for supporting this podcast on YouTube and on all major podcast platforms, including Google Podcasts and Spotify. The podcast mainly features interesting people in robotics, artificial intelligence, and entrepreneurship. If you believe that the information that I'm providing might be of benefit to you or to someone you know, it would be really great if you could hit the subscribe button and press the notification icon so that you can get notified on time whenever the next part is out. It would literally take you a second or two to subscribe to the podcast, but it would really mean a lot to me because I can grow the podcast to a level where I can reach more people, invite ever more interesting guests, and have a more meaningful impact. So let's begin now.
So let's begin with talking about what everyone is probably most waiting for. Let's talk about your professional experience as a robotics software engineer at Boston Dynamics. So, of course, everyone knows about Boston Dynamics, but maybe you can briefly talk about the company and then about your role.
Sure. Yeah. So Boston Dynamics has been around for a couple decades, and they're a pretty I would say pretty adventurous company that
That's a good
focuses
way
on
to put it.
yeah that focuses on really showcasing highly capable legged robots, right? A lot of the foundations of Boston Dynamics over the years and the viral videos that have come out have really been around bipedal, so two-legged, or quadruped, four-legged robots. And that's really, two of the three main products that Boston Dynamics offers today, or, well, I don't say products, but robots, are Spot, which is the four-legged dog-like robot, and Atlas, which is the humanoid robot used more for like research and showing off. So that's been a big strength of Boston Dynamics, in that the founding members have a lot of legged locomotion research experience.
Yeah.
My role in Boston Dynamics, as you've been saying, is not so much in that, but rather with the third platform, which is the Stretch robot, and that is Boston Dynamics' venture into logistics or warehouse robotics. So Stretch is essentially a mobile manipulator platform, right? It is a big robot. It's got a base with wheels, so it can drive omnidirectionally. It's got a 7 degree of freedom arm with a suction gripper, with the purpose of kind of manipulating boxes. So anything that has big flat surfaces is good for a suction gripper, like boxes. And it also has a pretty capable perception system in that Stretch has what they call a perception mast that sticks out from the base of the robot, and it's actively controlled, so you can point the cameras at a particular place and take pictures of things that you care about, particular things that you want to manipulate, like boxes, or things that you want to avoid, like everything else. So yeah, Stretch is of course what was unveiled fairly recently. And there's been a lot of growth in Boston Dynamics because of that, and I'm certainly part of that growth, in that I've been there for just 4 months at the time of this recording. So that's kind of the high level. Now, personally, I work on the what we call the behavior team on Stretch, and the way to kind of divide that up, without getting into too much detail, is so there's the two words that you'll see a lot in the robotics literature, which are exteroceptive and proprioceptive.
Okay.
Yes. So and those are just like fancy words for really saying sensing your own internal state versus sensing the state of the world. And I think that in most places, and also where I am, things are divided that way, right? So you've got your entire controls team, which will say, this is the internal state of the robot. Like, what is the state of my arm joints of my base, so that I can keep the system controlled and not hit into things. How do you track that? Great, you've got controls folks doing that. Then you've got the kind of the external facing perception team, which is, okay, using my sensors like camera, LiDAR, what have you, can you detect things about the world that you care about? Like I said, things that you probably want to interact with, like manipulating boxes, or things that you want to avoid, like the walls or other obstacles. So there are lots of folks on my larger team that are working on that, and we as the behavior team get all that information. So we know that the robot now has capabilities to move around. It knows hopefully where things are in the world, and we have to now kind of orchestrate all of that and make the robot do autonomous behaviors. So a lot of what we do is we have some aspect of planning, like figuring out if we're going to pick up something, how do we approach it? A lot of what we do also is how to make things robust. So failure recoveries in the behaviors, because robots, as much as we want them to be predictable, they often do things that we don't want them to do. So there's a lot of that we focus on, and it's been a lot of fun. I mean, we just kind of start with a problem that is very easy and scoped down. We get that solved correctly, and then we're like, okay, but in the real world setting, this is going to be more complex. So we start relaxing some of these assumptions, and therefore their behaviors become more and more complex. And we have to kind of manage that complexity in a way that the robot will still, run autonomously, won't get stuck in loops. If there is something that requires a human intervention, that it will communicate that to some kind of user. So it's really nice, kind of getting to work on a system with that much capability with a big team of people. Yeah.
Yeah. Yeah, thanks a lot for sharing that. So, also, the focus of Stretch is for a specific narrow application. So, for example, you mentioned about picking flat boxes, or is it other domains also that you're targeting?
Well, yeah, if you look at the Stretch website, the things that we are talking about there are things that require moving boxes. And the reason we say boxes is because the Stretch has, as you see, it's been designed with a suction gripper. So there are lots of other robotics applications that will have other kinds of grippers. Maybe they have like parallel jaw grippers, with actual antipodal pairs. Or maybe they'll have like smaller suction grippers to pick up, individual components, which people call each picking. So you think of, I don't know if you've seen like the Amazon picking challenge,
Yeah.
where you're actually, you're taking a bin full of like cluttered small things and trying to like pick them up. So that's like a completely different application. There's other companies doing that. In this case, the big suction gripper is all about moving, larger, heavy objects such as boxes. No, but what I'll say is, yeah, so what you'll see on the site is basically things around moving boxes, like unloading a truck, like a container that is full of boxes, and you'll see that in the Stretch release video, right? Where you kind of have a truck that is kind of packed with a bunch of boxes, and then the Stretch is a conveyor belt behind it, and it's kind of picking things up, avoiding obstacles to place the boxes behind it, and kind of helping do a task that would be very menial and for a human to do manually. Another thing that you see with boxes is the working with pallets. So for those not familiar with pallets, it's kind of a flat surface on the ground that's about like 2 meters by 2 meters, where typically when you're taking stuff out of a truck, you will like assemble a pallet, kind of like a stack of boxes, a little tower, and then a forklift will come and pick it up and take it elsewhere. So it's all about like helping like stack or unstack these things so that forklifts can then move goods around a warehouse. So that's kind of the way that the Stretch is kind of designed right now.
Yeah. So are you involved in mostly the planning and control side? You also mentioned about the mast that you have where the camera sensor is. So, or are you also involved on the perception part, or is it multidisciplinary?
It's pretty multidisciplinary. I think one thing that I've observed from my brief time here is that you're expected to be pretty flexible about what you work on. Like, you might have your area of expertise and so on, but for the most part, there's just a lot of things that need to be done, right? So in the projects that I've worked on so far, it might involve talking to the perception team to work with them on something, or talking to the controls team. So I don't know. It's also an aspect of the fact that I'm fairly new means that I'm purposely starting with tasks that are smaller and make me collaborate with other teams. And I think at some point you kind of find your your niche area where you get to maybe focus more and work on bigger isolated features.
Yeah.
But no, I think from my experience so far with my colleagues, everyone has a pretty good working knowledge of what other teams does because you need that to function.
Yeah, for
It's
sure.
a pretty collaborative environment. Like you have to talk to people to get information to get anything done. It's this complicated system. So
But
I really enjoy that.
also
Yeah.
for your work, sorry for interrupting. Also for your work, you have to be you're free to be involved in all the different interdisciplinary areas, or is it just that you are officially you have like one domain, but you have to have some knowledge about the other, interconnected areas?
Yeah, I think in my experience so far, I think we have enough people that you can really just find your footing. Like maybe you'll try out a couple of projects and realize that, hey, I think I work really well working more on the perception side of behavior versus on the control side. So I think inevitably by the projects that you have, what you end up being better at, what the needs of the company are, you might end up kind of falling into certain focuses, or even a couple of years down the line, you might even end up switching focuses. So I don't know, I really like that. I like variety in my work. Yeah,
Also from your previous experience, you have been I think everything you have done, you have done it in you have been involved in different fields simultaneously, even with education and other things. So yeah, you enjoy that basically.
yeah, I think so. Otherwise, otherwise I'd have a fun time. But yeah, no, I do gravitate to jobs that have a lot of variety.
Yeah,
Because
yeah.
it is what I enjoy. As far as like the kind of being more on the systems level of things rather than having just one very deep focus.
So the environment also about, I mean, the questions about Boston Dynamics, if any of these things are something you can't answer, just feel free to say that, right? So the environment, is it more of does the environment of Boston Dynamics look more like that of a research institute, a startup, or an established firm? You know.
Oh, that is a very, very good question. Um, it it's a combination of both. So my other two experiences have been at very extremes of that, right? Where like MathWorks is a pretty well established corporation, even though it's actually been around for about as long as Boston Dynamics. It is a bigger company. So that place is it's a pretty process driven corporate environment. That you get a lot of structure. There's which can be good, right? You get a lot of training opportunities. Things are, I don't know,
Like
if you
your
need
roles are
guidance.
defined. Your roles
Yeah,
are mostly defined. Yeah.
yeah, and there's always kind of guidance and kind of a process to get places. Whereas then I went to MIT where it's like, oh, you're like the one software engineer in this group currently. Can you just do
Do
things?
everything.
Yeah, and it's kind of a chaos that you have to embrace. I think Boston Dynamics has a combination of that, right? In that I think it still retains a lot of its academic environment because a lot of people that come into Boston Dynamics have been doing research, right?
Yeah.
Particularly for the legged locomotion work. So there's still that like startup like agility, the whole like build fast and break things
Yeah.
type mantra. But at the same time, there is increasingly as the company grows, there is an increasing need for more support. And I think the support, one thing that I see a lot is, for example, something that I would have really liked to have help with at, say, MIT is having like a software platform team. People that will take care of things like setting up your repositories, your continuous integration,
Ah.
like all the foundational software that makes you productive at your job. Because otherwise, you either have to do a lot of that software engineering yourself, sacrificing the engineering work, or you end up just cutting corners and having like barely working demo code. Uh, so I think that there's some happy medium in there, in that there is still a lot of engineering rigor, but things do move a lot quicker than maybe some other more corporate environments. So it's a good mix. I enjoy it.
Yeah. So that's interesting to know, right? So it's still, of course, it has to have the startup spirit because because we see the kind of things that Boston Dynamics is doing. So it has to have that because it is constantly. It's a very innovative company, simply put. So, but at the same time, you mentioned that there's also a structure involved. So it's a balance of that, and of course, the background of a lot of the employees are from research, so that also feeds to it. So that's really interesting to know. And what do you enjoy the most about your journey so far at Boston Dynamics?
This is this is a silly answer, but I I enjoy being the dumbest person in the room, and that is true not just in Boston, not just in Boston Dynamics, but in general. And what I mean
Yeah,
by that, like
yeah.
I am kidding, but it is the fact that I get to work on a team
You
of
get to
really
learn
talented people.
from
Yeah,
so many people is what you want to say, right? Yeah.
exactly. So there is such a high concentration of knowledge in this place. Um, it's something that I place a lot of premium on myself in looking
Yeah.
for a job is the chance to basically be learning things every day.
Mm.
All of my teammates, these are people that are, like, a lot of my teammates are even fresh out of school and they know so much about things. It's like it's delightful to get to talk to my colleagues and just pick their brain about how to solve problems, or
Yeah, yeah.
what is the latest uh, what is like the latest C++ standard, and some trickery that you can do to make your code look super clean. I don't know. There's all sorts of cool things that you can pick up, and even reaching across different teams, right? Like there's people that have been working on, say, the Atlas robot that have years of experience doing things, and we get to learn a lot from them. So yeah, getting to work on getting to just absorb knowledge from people, but also just working in a collaborative software team, right? I think if you are working on software but you're doing your own projects, like you're doing your own demo or your own educational content, at the end of the day you're not really writing code for anyone else with anyone else. Like, you're putting something together that you think is good, you're putting it out there, and people may or may not use it. But when you're actively working with a team and everyone's kind of touching the code at the same time, you're like stepping on each other's toes. You learn a lot more about software engineering than if you were to work on your own. So
Okay.
I think working in a software team where everyone, like, you're co-developing with people live, is also a great part of this work compared to the other things that I'd been doing before.
So working in a fresh and innovative environment where you can brainstorm ideas and just cherish on those discussions that you would have. Uh,
Exactly.
yeah, that's really cool. Sure. Uh, okay, so before Boston Dynamics, you have also worked at MIT CSAIL lab, right? The Computer Science and Artificial Intelligence lab, is how is it
That's right.
called?
Yep.
Yeah. So where you have been involved in more of the research side of robotics, can you also briefly tell us about your experience there and what are the things that you were involved in?
Yeah. So this was a really interesting job. And it was, it's not a typical job that you find, which I thought was really cool. Um, Basically, it worked this way. So CSAIL particularly, they have certain collaborations with industry, right? So there had been a joint venture between CSAIL and the Toyota Research Institute, TRI,
Yeah.
where they've got kind of a bunch of sponsored grants with different groups in MIT to pursue different research avenues. Particularly, like, what Toyota Research really does is a combination of automated driving and home service robotics. So the project that I was on was, again, sponsored by TRI, and focused in on the home service robotics aspect, where several researchers, several principal investigators within CSAIL were trying to use the specific Toyota robot. This is the human support robot,
Mm-hmm.
um, to perform home service robotics tasks, really based around grounding natural language to certain executable things in the world. So there's actually an effort, across lots of different researchers, but as far as, like, officially being employed, I happened to fall into a specific lab group, and that was the robust robotics group, headed by my former boss, Professor Nick Roy. so I was officially a part of his team, and so I got to work with a lot of the grad students, and so on. I was a software engineer in that lab, but really I was put in there to work on a project for this Toyota initiative. And the way that worked was, every couple of months or so, MIT had to present to Toyota like, hey, this is what we've been doing with the robot. We've been doing some research, and here's a demo on your platform showing what's going on. Uh, and they never really had software resources to do that, which, like grad students want to focus on research. So getting to do a demo for like a corporate sponsor is always a challenging thing to do that takes away from the student's research time. And I think having the resources to have engineering support for that is really, really useful for actually, bridging that research industry gap. So my job was, I came in, we had a Toyota human support robot in the box. We had the new version just still packed up in the box. I came in and they're like, hey, Sebastian, can you, unbox it and make it do things? Like, okay, make it do what? Just everything, so it was really fun because the goal of my project coming in was really, we have all this research going on in very specific things like, natural language grounding, task and motion planning. But in order to show that in a real robot demo, you need your robot to already have basic capabilities. Like if you're going to show the robot responding to natural language and picking up an object, maybe the grad students did the research on the language part, but can the robot navigate? Can it detect objects? Can it manipulate objects? So for me, it was just standing up the robot that you could command it to do stuff and then later on bring in the research. It was a really good learning experience because I had to basically get the robot working in every single aspect. The robot has a ROS interface, so I got to use a lot of the existing APIs like the ROS navigation stack to get the robot to like map out its environment and move from point A to point B. That worked fairly well. We had to train our own models for our demo, so we were doing home service tasks. So we basically had the robot, take pictures of objects it was interested in. We labeled our own data. We trained our own models. We did the same for language. We generated our synthetic language data, trained neural networks for that. And
so
then
you were involved in a little bit of everything there and this was also something you were doing from scratch, let's say, right? So you got the robot and you had to pour all of your creativity into making it do all the service tasks.
Exactly. So there was a lot of learning, certainly, and a lot of creative freedom, like you're talking about. And I thought that was really cool because one thing about that role is that because it was, in academia, I actually got to share this information pretty openly. So, and that was just after I'd come off the MATLAB and Simulink Robotics Arena role. So I said, you know what, I'm still learning a lot of stuff. It's not with MATLAB necessarily. I'm just basically writing a bunch of Python code to train object detectors, to create behavior trees for a robot to execute tasks. I was like, I need to learn this anyway, and I think it'd be really good if I wrote about it. And that's where I kind of started my own website as well, in parallel to my MIT learning, where it would help me learn the concepts better, and then people could also kind of consume what I learned on my site. So it was really rewarding because I got to kind of, do two things at once. And by
So
the
is
end of
it the
that year,
same website that you have currently, or robotics base or something like that, right?
yeah, that's roboticscbas.com. I actually
Yes.
started that shortly after I started MIT, as I
Oh
started.
wow.
Um, yeah, by the end of the year, we were able to have the robot, do pretty capable demos where we could speak to it and it would, respond, go pick up things. We integrated a couple of fun research projects around grounding objects from combined vision and language, and then also got to integrate some task and motion planners to think about like long horizon tasks on the robot. So that was really cool, and all in the span of a year basically, which was just very accelerated learning.
Mhm. Yeah, sounds like in all of your experiences, you had the exposure of trying out things and learning it by playing around, let's say. So that's pretty interesting. So before that, you were at MathWorks and creating content. Can you talk about how you came across this opportunity and also about what you were involved in specifically? And of course, your content is there available for free for everyone, right, on YouTube and also on MathWorks website. But yeah, can you elaborate on that?
Yeah, of course. So I was on a team that is a pretty small and focused team in MathWorks' education department team, which focused on adopting usage of MATLAB and Simulink in student competitions.
Hmm.
And the way that this really started was one of my colleagues and a good friend of mine, Christoph Hahn. I don't know if you've seen this before, but he and one of his former colleagues developed a podcast for the Formula SAE or Formula student competitions called the MATLAB and Simulink Racing Lounge.
Oh.
Um, he had these really cool podcasts where he would talk about like, oh, how do you do race car engineering things like lap time simulation, battery modeling with MATLAB and Simulink for your like racing competitions in university. And he got to interview a lot of student teams that way too. And that was super popular. Um, he was doing that for a couple of years, and then it became very evident that, hey, robotics is another area where like there's a lot of high school and university competitions where people are learning hands-on skills. So what if we did the same thing as that Racing Lounge podcast, but for robotics? So when I came into that role at MathWorks, myself and a couple more of my colleagues, we said, yeah, let's make a robotics video series and just show how to use MATLAB and Simulink for whatever we think is useful in robotics. So that's where we created the MATLAB and Simulink Robotics Arena, and that was in, I guess, early 2017. And we started that, like my background was, like I said, was in modeling and simulation. MATLAB and Simulink in general are really good tools for modeling and simulation. So we started with a video that is still, haunting my dreams up to today, but it's a walking robot video where I was showing people how to model, this little two-legged robot using Simscape multibody, doing the contact mechanics, and having the robot walk around. And actually, looking back on it, we did a terrible job at that because we were thinking a lot about how to simulate the robot, like how to simulate the mechanics and the motors, but we were ignoring the part about legged robot control. So we put this content out, and people were trying all these things. And as it became more popular and we got feedback, there were actually people that I got to collaborate with within MathWorks that had a lot more legged robots experience, and like we worked together to actually make that content better and refresh it. And it just kept going. Like the walking robot became a super popular thing in the MathWorks canon, where in 2019, MathWorks released a reinforcement learning toolbox, and we took that walking robot model, and as well as the DDPG paper from reinforcement learning, and we said, hey, why don't we make that work? But instead of the Mojoko Walker, we make it work with this MATLAB walking robot, and it did, and that was like a really cool example that we got to work on. So yeah, we were working on these videos, getting a lot of exposure out there, and like you said, lots of students are stumbling upon these videos on YouTube.
Yeah, that's a pretty cool experience. So here again, you were involved in. This is something that the MathWorks was planning to do it. So you were involved from an initial phase, right? So I think a part of your strength, and also this is something that you love doing, right? When you're given something to do from scratch, let's say, and you have to figure things out, like a more creative way of doing it, and if it involves technology from different domains and disciplines. So, and how did you deliberately apply to MathWorks, or did how was the process like?
Yeah, that was back in the day. Oh, I'm dating myself here. Yeah, I did apply to MathWorks. So I studied mechanical engineering, and I think it's still true today that particularly the engineering students have a lot more exposure to MATLAB than other fields. So I was doing pretty much exclusively MATLAB during my undergraduate career, except for my master's research that was Python based. So I had a lot of experience with MATLAB, and it was one of those companies that like when they came to career fairs in university, you recognized. It's like,
Yeah.
oh yeah, it's the MATLAB people. Let me go talk to them. And it was a really good experience. You know, that they recruit a lot in universities for their entry level program, which is called the Engineering Development Group, where you kind of go in as a like fresh out of school person. You don't know what you want to do, and you get to just try a bunch of things and kind of do projects with other teams and find your way into maybe the training team or the development team or the quality engineering team. So it was just a good experience to go through that. It felt a lot like school because a lot of my colleagues at the time were also people in their early 20s like myself. So it was a really nice experience. And I did last there a long time for that reason.
So the reason why I'm asking this is I want to know how you ended up in the education department, because probably that was also at a very initial stage, right? At that point.
Yeah. It was. I remember having a really funny conversation once with one of the managers, because we used to do technical support, right?
Yeah.
So essentially we would take calls from customers, and like any tech support thing, you want to answer the customer's question as quick as possible and move on. Move on to the next thing, keep it moving. I remember one time I was on a phone call for 2 hours with a customer because I kept showing him how to do things, and like we were learning a lot about how to use the tools. And the manager pinged me on the chat and was like, "Hey, by the way, this is not a training session. Just it's like tech support. You should answer the question, wrap it up, and move on." I was like, "I really like to do this." So I got involved with internal training opportunities where, like, I started developing materials and teaching materials to my colleagues in the same team. Like, as you get new hires, they come through training. You teach them how to use MATLAB and Simulink, and that was a lot of fun. And I just kind of I went from the internal training to the external training, which is where we actually develop material for customers, like professional customers that paid for training. So we created, really professional training materials and examples. And as we got more and more refined with our content, it was first, internal training where you're just like PowerPointing to someone, then writing manuals, and then creating YouTube videos for, like very polished YouTube videos for audience. I know the reach that you get from like putting more and more effort into educational content is pretty rewarding. So it was a good progression. Yeah.
Yeah. I like the story that you shared. So it started with a training call that you were doing, and then slowly it evolved to what it is right now. Let's say the education section in MathWorks. Uh, Pretty interesting.
Yeah. So like basically all the YouTube videos that we were doing was one part of the job that we had, but we worked on a competition team where we, in addition to just making generic educational content, we would actually engage with strategic competitions. And one of the biggest robotics competitions that exists today is RoboCup, which
Yeah.
started, I think, in the 90s, where they were trying to do robot soccer or football for everyone that's normal,
Yeah.
not in the US. But yeah, so the idea was that RoboCup, um, they have corporate sponsors, and MathWorks is one of the main global corporate sponsors. So we had a program where we would, provide sponsorship to RoboCup, and they would invite us to then have our own exhibition booth, to give presentations, to talk to the students in the competition. And my job, in addition to the educational content, was to actually travel to RoboCup events or like do webinars, and get to basically, do field research. Like, what are people doing in these competitions for robotics? How could MATLAB and Simulink help? And if it can't help in certain parts, why? You kind of give that feedback to development. So yeah, I got to basically just go to these events and see what people were doing. RoboCup doesn't just have robot soccer nowadays. They also have search and rescue leagues. They have logistics and warehouse robot leagues. They have a home service robot league, which is actually how I learned about the Toyota robot that I then used at MIT. So I think that experience actually helped me get my role at MIT in some way. But it was really cool. I mean, I got to travel all over the world. I got to go to Germany a lot. I got to go to Japan, Australia, Thailand, France, just to see all these events and get to talk to students all over the world about what software they were using to work with the robots. And yeah, that was a really eye-opening experience, and I learned a lot about just the lay of the open source world of robotics tools, to the point where I then wanted to pursue that further in my career.
Yeah. What was the most interesting part of this journey at MathWorks for you?
The most interesting part of the journey, I think the most interesting part was getting to give back to the development teams. So when I was in the last role, my latest role at MathWorks, with all the robotics work we were doing, we actually got to contribute to the actual toolboxes. So I actually got to do things for the reinforcement learning toolbox. I mentioned the walking robot.
Yeah.
It's kind of one of the flagship demos, and I did a lot of work also for the ROS toolbox that came out. I also got to work on demos for that, like internal training for teaching people at MathWorks how to use ROS. So it was nice actually getting to like becomes a form of domain expert within the company on something.
Yeah.
That felt really good. That your all the effort that you put in actually helped give back to other people in the company and to make the
Yeah,
product better. Yeah.
That's a pretty unique role, right? So you were creating educational content, but at the same time, of course, you were in a sense researching, right? I mean, you were building your own. So like the student as research assistants would do, you were making these sort of assignments, so to say. So you were making these MATLAB tutorials. You were doing research. You were doing educational content creation. You were also traveling and meeting people. So it probably gave you a well-rounded experience. I mean, these are the things, right? Either you are into deep into research, or you are into, let's say, programming or engineering for a company, or you are into people skills. But this was sort of everything combined together in a very interesting way.
Yeah.
Yeah. So now let's talk about your thesis topic, high-level control of modular robots. And did you choose this topic, or did you accidentally come across this, or did you apply for it? And how does this topic play a role to your current position, so to say?
Yeah. I did not choose this topic, so it was when I moved from my undergraduate to my master's program within the same school. Obviously, you have to find your research project to do, right?
Mhm.
And I had recently taken a class by, at the time, a new professor, Professor Hadas Kreskazit, who had just come in from UPenn, and her specialty is on kind of verifiable robotics through formal methods, particular linear temporal logic. I took her class on autonomous mobile robots, which was a brutal but very useful class where you basically, like, on any given day, like, you had your homework assignment where it was like, okay, implement Dijkstra's algorithm and A star and a probabilistic roadmap and an RT and a SLAM algorithm, go. So it was a really hard class because you had to implement all these mobile robotics algorithms, but it was
Yeah.
so cool that I was like, I need to see what Professor Kreskazit has in terms of research. Like, I want to work more on this. So again, like I said, she had just come in from Penn, and she was starting her own group. And what she brought with her was a software tool where you would type in what you called structured English, so like a natural language type thing. You would say things like, "Oh, if you are sensing a fire, then never go into the kitchen." That would then get synthesized into a linear temporal logic formula. And once you have LTL, you can basically apply formal methods to guarantee that your robot behavior will never violate that specification. That's kind of the high level overview. So she had all this in place. You would write in the structured English, and then you would, out of it, you would get this hybrid controller where at any point in time you could tell your robot you know which region to navigate to in a world. If you're sensing something, to avoid certain regions. Great, that's all in place. What a lot of her master's projects was, can we demonstrate this not just for like a 2D point robot, but to actually show it for a variety of different robots. So some of the other grad students that were there were like, okay, I'm going to do this for a legged robot, I'm going to do this for a hexapod. And for me, the platform that in question was to do this with these modular cube robots that these are these little cubes you can screw together in different configurations. So the idea was, can we do that and additionally enrich that with information about the configuration of the modular robots. So for example, your specification could be if you are near a tunnel, adopt a gate or adopt a configuration such that you can move low to the ground and move quickly in a straight line. And that you could then guarantee behavior where you'd say, oh, based on my library of known configuration and gates, I think I want to adopt a snake configuration that can crawl through the tunnel. And then when you get out the tunnel, it will transform into, a quadruped so it can walk faster, whatever. Is very academic. So it was I think that was kind of the birthplace of my systems thinking, right? Because there's an entire system in place, and now we're just gonna like modify one little piece to make it work for modular robots. In that process, I got to work with the real cube robots. I got to actually write my own 3D simulator for the robots where I could transform them on the fly. And I got to train the robots how to walk based on objectives by using genetic algorithms. So this was like, pre-reinforcement learning boom where people were just like throwing evolutionary algorithms at their problem. So it was really cool. I just got to do like a little bit of everything, integrate my stuff with the existing software system. That's where I got to learn Python, which was very useful later on in my life. And I was fortunate enough to get a conference publication out of that too. So it was a good master's experience. Yeah.
Yeah. Seems like a pretty intense thesis, And you also mentioned that you developed a systems level thinking from by working on this project. Can you also elaborate on that and maybe also lay an emphasis on to what importance systems level thinking has specifically for robotics?
Yeah. Okay, so I can think of a couple things that I learned from this project. One of them was a focus on modularity in software systems, right? So the software platform that I inherited was made in such a way that no matter what robot you used, your robot received basically like a target velocity vector, and then you had to write your own handler that said, okay, given my target velocity, can I make my robot like move towards that and like track the command? So that really stuck with me, right? Saying that you have to be thinking about this. If at any point you have this like general purpose planning algorithm and you want it to work for lots of different platforms and lots of environments, how do you really chunk up your system to make the interface clean? And the second thing was something that I still do a lot, which is the notion of switching between simulation and the real world. I got to work with both sim and hardware, and architecting your system to work seamlessly when you switch between those two in a way that isn't over-engineering your simulation is very, very difficult, and I certainly made a lot of mistakes along the way there. But yeah, it taught me a lot about the role of architecting a good system, again, for switching platforms and also for taking full advantage of simulation in a productive way. Like simulate only what you really need to simulate just to get like behavioral equivalence to the hardware, but don't try to recreate the hardware like one-to-one. That's an entirely different problem of sim to real, right? Basically, make the simulation as good as it needs to be for you to like debug your design and do as little work on the hardware as possible to like retune it.
Yeah.
So that's what I learned as like my two systems lessons from that project.
And you still use it in your let's say current and previous roles, this carry forward with you.
Absolutely. I mean, I use simulation to my benefit as much as I can, and then also like splitting up your system in functional components. It's something that if anyone is learning ROS, you will learn that the hard way anyway, and that everything is split up into nodes. But it's that same kind of thinking where you want to have specialized software components instead of one big monolithic piece of code that is impossible to debug.
Okay. Yeah, that gives a structure that is then easier to operate.
Yeah.
Okay. Yeah. And another thing. So moving back to your overall journey, right? So we talked already that you have, of course, been a specialist in some areas of robotics, but at the same time you have a more broad view as well. So for someone who is, let's say, a beginner in robotics, or even who has some years of experience, do you think it makes sense to just specialize in one area, or to have an interdisciplinary or a mix of both?
Um, it does depend heavily on what you want to do, but I I do agree with the concept of the T-shaped engineer. I don't know if you've heard that before or other people
Yeah.
have brought it up. I'm sure people have brought it up even in this podcast, right? That it's a T, so you basically have like a base level at the front here, which is like you know a little bit about a lot of different things, but then
Mhm.
you also need the vertical part of the T, which is your deep specialization. And I think that's a really useful thing to have. I mean, I think as much as we want to be really good at everything, it's just not going to happen in one lifetime.
Yeah, it's really not
So
possible.
yeah, so I think um, being broad is good at two things, right? One is just while you're educating yourself, you don't you don't yet know what you like, and I think having broad exposure to figure out what it is you like is super important.
Yeah.
Like in my case, I studied mechanical engineering, thinking that I'd be, like doing mechanical analysis, like stress and strain. But by being exposed to all the different fields in mechanical engineering in during college, I was like, you know what? I think I prefer like the mathy side, the dynamics and the controls, and like only by taking, like four years worth of classes,
Mhm.
could I even get to the point where I started developing a preference. So definitely expose yourself to that. The other benefit, of course, of the broad thinking is that especially in robotics, you can't avoid crossing disciplines.
Mm.
Uh, Even if you're not good at everything, which it's not going to happen, you need to understand how other people in your organization work. Like if you're a programmer but you don't know how to build things, you still need to know something about how the robot is built or like how it's designed. Because if if someone designed a robot with actuators that can only handle, let's say 1 Newton meter of torque, um, you need to at least know that level
Yeah.
of limitation so that you can program your robot to keep within those bounds, even if you're not touching the hardware yourself, right? So yeah, you need to know. It's good to learn more about what you like, and you need to know how to work with other people. On the other hand, uh, specialization is important because if you are a jack of all trades, master of none, then why would someone hire you? Like
Yeah.
in a place where you're in a team of 100 people, how do you stand out? So I think having something that you're good at, passionate about, that you want to learn, um, is is key. Like there has to be something that you bring to the table in addition
Mm.
to just like, I understand what everyone else does, but I don't contribute anything. Yeah. Um,
But with, let's say, the positions that involve education, uh, so for example, for your MathWorks profile, so
mhm.
you were, of course, you were making content mostly in one or two areas, maybe three, so to say. But for a field like education, do you think the having exposure to different roles help, or is it a better thing to be a generalist and understand the best way to, let's say, teach different
Yeah.
domains, or still be specialized in one area?
Yeah. It again still depends. So let me first say that if you're a generalist educator, your specialization, the deep part of your T could just be that you're a really good teacher. That is a specialization, right?
That
There are
that's,
lots
that's
of
an interesting view.
there's lots of really good roboticists that cannot teach a thing, right?
Yeah.
So that is a skill in itself. But also it depends on what you focus on, right? Like let's say you work in like an education team where yeah everyone knows a little bit, but maybe you're the person that knows a lot of C++. So you're gonna be the like specialist in education to get kids to learn about programming. That is
Yeah.
a specialization too. Like I think
But you
robotics
have to have
nowadays,
a
yeah, yeah,
specialization. Is
yeah. It just doesn't necessarily have to be a technical skill,
that's
even
an
though that's a common
interesting view.
misconception. Yeah.
Yeah, that's an interesting point, because with specialization, we would say that specialize in, let's say, natural language processing or computer vision, but you mentioned that, even teaching, let's say, C++ or something could be a specialized skill, and at the same time you have the top portion of the T, right?
Yeah.
And another portion that you mentioned was that, of course, you have to explore a lot of different fields to realize that which area I want to specialize in, right? And so
Yeah.
this is something that I relate with the reinforcement learning view of exploration and exploitation,
Oh, yeah.
so exploring different areas and then exploiting of one of the domains.
Yeah. So I
In that.
guess the takeaway is for all you viewers out there, be epsilon greedy. We'll be good there.
Yeah. That's a good, let's say, summary for this.
Hey guys, I really hope that you enjoyed this particular conversation and it helped you in some way, shape, or form. If it did, make sure to hit the subscribe button and the notification icon or the bell icon so that you can get notified on time whenever the next part is out. Also, it would be really great if you could give me your feedback in the comments below. That would really help me improve. I'm uploading small clips of the long podcasts on a regular basis on platforms like LinkedIn, Facebook, and Instagram. So make sure to follow me on these platforms if you're someone who cannot take out time for the long episodes. The podcasts are also available on all major podcast platforms, including Spotify and Google Podcasts.